Hello and welcome to the next video of the Checkpoint Lab. Today we will build a new topology to test how to configure site-to-site VPN tunnel between two checkpoint firewalls under the same smart management server. On the screen you can see topology for the second lab of the checkpoint firewall, and this lab will be about the VPN. So in this topology, we see that lab gateway number 1 and lab gateway number 2 doesn't have a sync interface anymore because it is two separate firewalls. And we will be setting up a VPN going from gateway number 1 to the gateway number 2, like this. And this will be the site-to-site VPN. Both of the gateways are managed by the same management server, and the test traffic will go from Ethernet 1 of lab SMS. It will go through the lab gateway number 1, and then it will go through Ethernet 1 to Ethernet 1 of lab gateway number 2, and then through the Ethernet 2 of lab gateway number 2, it will arrive back to Ethernet 2 of the SMS. And the trick we will have to do is not only to configure the VPN, we will also need to configure a source net on gateway number 2 in a way so that LabSMS will not know that it is essentially pinging itself and creating a test traffic from one of the interface to the other interface of the same server. On the other hand, we will need to configure a destination net, DNet, on lab gateway number 1. We need a destination net because LabSMS should ping some IP address which does not belong to neither gateway 1 nor to the gateway 2, and also it cannot be self-interface, so LabSMS cannot ping Ethernet 2 through all this traffic. It will just ping the Ethernet 2 directly, and no packets will ever leave LabSMS in this scenario. So having the destination net translation and source net translation, we will be able to mask the traffic behind netting, and this way we will be able to create this traffic loop to test how traffic goes through the VPN between two firewalls. At this point, we already have all the VMs set up and configured with the IP interfaces, and what we need to do, we just need to complete the first time configuration wizard for the firewalls, and then we will add these two firewalls to Smart Console as separate gateways. So as the first step, let's double check if we have all the addresses set up correctly. For this, we can do just ifconfig. And here we see that we have a management IP address, we have the IP address which we will use for the VPN connection, and we have an additional address which we will use for testing. So this IP is connected to the Ethernet 1 of the LabSMS. Let's connect now to the second firewall. On the second firewall, we have also a management interface. We have the IP address which will be used for the VPN. It is Ethernet 1, and then Ethernet 2 will be used for the testing. This IP address is connected to the Ethernet of the LabSMS. Let's go ahead and complete first time configuration wizard for both firewalls. We can click next, then we continue, and we already have this IP address configured. We have Ethernet 1, so here we will just repeat the IP address that we already have, and it is .1, and it will not ask any other IP addresses, so we already have the host name. Do not touch the time. So that security management or security gateway, we need only security gateway, and it will not be part of any cluster. So we do not check this checkbox. Go next. No, we will not get the IP address dynamically, and we will need activation key as always. Then we click next. Now let's repeat. And we don't want to send any data. We can finish. Now let's go to the second firewall. Same we do here. And here we just repeat the IP address we already have. It's .2. Now we click next. We already have the name. Then we don't touch the time. We need only security gateway, not part of the cluster. Click next. No dynamic IP, activation key. And now we can finish. So let's wait until first time configuration wizard is completed on both the firewalls. We see that first time configuration wizard is now complete. We can log into the Smart Console. In the Smart Console, we will need to add two separate gateways for WAP gateway number 1 and the other one for WAP gateway number 2. And also we will need to enable IPsec and VPN software wait. It is just a gateway. So gateway name is WAP gateway 1. The platform is an open server, and the IP address will be 192.168.43.2. One-time password. And now we can next. That's the topology. So that's the summary we have. We can create the second gateway. Again, it is an open server. Okay, here's the topology. Here we see the two gateways that we just created. What we want to do before publishing and installing policy, we want to enable this wait for IPsec and VPN and click OK. And we will do the same for the second gateway. Now we will check what we have in the policy. We will, as usual, change the cleanup rule to make it accept and block. And now we can publish, and then we will install policy. As we see, instead of a single cluster object when we making the policy install, now we have two separate firewalls. So we have the policy installation successful with just a warning, which we can ignore, and we can close. Now let's go through the step to configure the site-to-site VPN between two checkpoint firewalls managed by the same security management server. The first step would be to go to the gateway settings. In the gateway settings, we will need to change the topology for the Ethernet 1 interface and make it external. And then we can go to the VPN domain. In the VPN domain, we will change the VPN encryption domain for the manually created. I have prepared the lab gateway number 1 encryption domain, which is the network connected to the interface of the smart management server. Now we can go to the IPsec VPN settings and link selection. Here we need to change the address used for the establishing of the VPNs to the external IP address of the firewall here. And now we can click OK. Let's do the same for the gateway number 2. Changing the topology. Then defining the VPN domain. And then changing the main address to the selected address from the topology. And we can click OK. Now we should go to the security policy and create a new VPN community. We have a couple predefined VPN communities, but we need a new one. It is star community, and it's lab community in our case. So the gateway number 1 will be the central gateway, and the gateway number 2 will be satellite gateway. That's the two peers of the site-to-site VPN connection. For the encryption, we can set up the parameters for phase 1 and phase 2. We can change something about tunnel management, VPN routing, map, multiple entry points, excluded services, shared secret, wire mode, and advanced. And basically, we will not change anything right now. What we want is just to set up the site-to-site VPN without changing any significant parameters. Really, we have nothing to change here because both of the gateways are managed by the same management server, and both of the settings automatically will be applied to all the gateways inside the same community. It would be a little bit different story in case if we have one gateway managed by one management server and the other gateway managed by the other management server, or if we have a VPN between a checkpoint and some other vendor. In this case, the parameters for phase 1 and phase 2, of course, must match between the peers of the VPN connection. But in our case, it will be performed automatically and we can leave it as it is. Of course, you can build this lab and change all the parameters you want to test how it works and what changes when you for example, change some phase 1 or phase 2, or when you change, let's say, timers for phase 1 and phase 2. The only thing I want to mention is about tunnel management. So we have this VPN tunnel sharing. In the default configuration, we have one VPN tunnel per subnet pair, which makes sense. And but in case if you have a checkpoint setting up the connection with some other vendor, I highly prefer to change it to one VPN tunnel per each pair of hosts, because sometimes checkpoints summarize the networks in a bit different way rather than other firewall vendors to propose an encryption domain in the VPN proposal. So it's always better to make it more specific rather than more broad. Now we can click OK. So we have the web community, which is star community. If we go back to the firewalls, we can double click. Now we should be able to see that this firewall is part of web community. Before it was empty. And on the same page, we can see the VPN certificate. And this VPN certificate was issued by the internal CA. And that's the case for the both of our firewalls. So they will use a VPN certificate to build the tunnel, and that's why we don't need any pre-shared secret. In case if these two gateways would be managed by different smart management servers, then and we want to use a certificate to build the VPN, then the certificates would have to be exchanged between smart management servers to make it trusted both ways. Okay, the next step is to create a net for our traffic. Because of the topology, we cannot directly establish a connection from one interface of smart management server to another interface of smart management server. We need to create some net rules to do so. So let's create a net rule, manual net rule below. We will call it a VPN destination net. And this VPN destination net rule will handle traffic from the WebSMS Ethernet 1 IP address, this one, 100, and we will go to our imaginary address, which is the DNet of WebSMS Ethernet 2. So that's this IP address. We must ensure that source IP address belongs to local encryption domain of the web gateway number 1, and the destination IP address belongs to the encryption domain of the web gateway number 2. This way, web gateway number 1 will understand that this traffic must be encrypted rather than send it clear text. And we need this destination net because WebSMS cannot ping self-interface through some different device, even if you will add a static route and the destination network for the static route is the IP address of the interface which is local to this machine. The route will not be added, and that's why we need to add some IP address from the same network as the encryption domain of the web gateway number 2. Okay, so that will be 200.101. And then we should translate it to the correct IP address of the WebSMS Ethernet number 2. So this one. This way, this traffic will go to gateway number 1, will be translated with the destination, and then should be sent to gateway number 2 through the VPN tunnel. This is not the only net rule that we need to create. The other net rule should be a source net rule. So we will create a new rule below. That will be VPN source net rule, and the source net rule should be configured on the gateway number 2. So let's set up the target right now. The policy install, and this rule should be created on gateway number 1. We will have the packet where the source will be the original packet of WebSMS with Ethernet 1, and the destination will be WebSMS Ethernet 2. This packet can perfectly reach the destination, the Ethernet 2 IP address of the WebSMS. but the source IP address will be the same IP address which we have on the WebSMS itself, so it will be not right. What we will have to do, we will have to hide this source IP address behind some IP address on the gateway number 2. So we will search up gateway number 2, and I will use already prepared object for Ethernet to source net on gateway number 2, which is 199.200.200.201. And we need now to set up the original source and original destination of the packet. So original source will be the same as we had before. That's SMS Ethernet 1 IP address. And the original destination in the packet which will arrive at gateway number 2 is this one, because it is already translated by gateway number 1. Ethernet 2 IP address. Okay. With this, we have all the NAT translations that we need. And we can now publish and install the policy. And policy install. Okay, policy installation is successful. Just to summarize what we did, so we created the new firewall community for our firewalls. We created the NAT rules to mask the destination IP address and then to hide the source IP address. This way, the packet from WebSMS can reach to itself Ethernet 2 IP address through the VPN tunnel. The only thing which we are missing is the routing. So we need to configure routing. The first route we need to configure is on the gateway number 1. We will log into Clish. In Clish, we need to configure the default route, which will tell the gateway number 1 that whatever network we don't know about, we should go and reach through external interface of gateway number 2. So we will do the command set static route. Then we put the keyword default, nexthop, gateway address, and the address is 100, 100, 102, and we need to enable the route. We can exit, and now we can log into gateway number 2. Go to Clish, then set static route default, and nexthop gateway address should be 100, 100, 101, and then we enable the route. This will allow any traffic which each of the gateway does not know about go through the other gateway, and essentially it will send the traffic through the VPN tunnel in the future. Now we need to create routes on the WebSMS. We need these static routes on WebSMS to explain to this server how to reach the NAT IP addresses, because nobody will reply to the ARP for the destination NAT IP address or source NAT IP address. That's why we need static routes to make this connection consistent. So we will set static route, and the destination will be the NAT address that we configured on the gateway number 1. So this is a destination NAT address. We can double check, so that's the address. We can copy, then static route for the host, and then we will do nexthop gateway address and the IP address of the interface on the gateway number 1, and we can double check what it will be. It is 199.100.100.1, and then we make the route enable. The next route we need to add is the route to the source NAT IP address on gateway number 2. So we can again double check what is the destination IP address which we want to be reachable. That's this one. Now we do the same command. We will set static route, and what we will change here, first of all, it should go through Ethernet 2 of the gateway number 2, and then it's the source NAT IP address instead of destination NAT IP address. And this way we will also enable the route. Let's save config, and now we can exit. After we added the routes, we can test the connectivity. What we can do, we can log into WebSMS. On the WebSMS, we will try to ping the NAT IP address which we have on the gateway number 1. It is 199.200.200.101, and we see that this ping is successful. Okay. To confirm that this traffic was encrypted, we can go to the logs. Let's do a refresh. And in the logs, we can see that essentially we have the key installed between the two firewalls. In the details, we see that that's a VPN tunnel establishment for the lab community. And here we also have a lot of details about what's going on exactly. So we can see responding cookies. We can see the subnets. So that's between the 100.100.0 and 200.200.0 subnets. And basically, this confirms that we have the VPN established. The next packet we see here is the encrypt packet. The encrypt block is from the gateway number 1. What's happening here is that this is the source IP address. It goes to the destination IP address. It is encrypted and destination net is applied. So the new destination IP address is the IP address of Ethernet 2 interface of WebSMS server. We can also see that it was encrypted in community web community. And the following packet is the decrypt packet. The decrypt packet is on the web gateway number 2. We again see what is the source. That's the source IP address in the original packet. This is the destination IP address in the original packet. Then it is a source net applied for this packet, and we hide the source from the other network behind the source NAT IP address on WAP gateway number 2. And this traffic is encrypted in, this traffic is decrypted in the web community. Okay. Let's review a little bit more on the network diagram. On the network diagram, we have 3 main parts of the traffic flow. So the part number 1 is from the Ethernet 1 IP address of the WAP SMS to the Ethernet 2 IP address of the WAP gateway number 1. The part number 2 is the traffic in the tunnel here. And this is encrypted traffic in the WAP community. And the part of the traffic number 3 is the traffic from Ethernet 2 of WAP gateway number 2 to Ethernet 2 of the WAP SMS. So that's the part number 3. And between WAP SMS and gateway number 1, we have packet with this source IP address and destination IP address. We monetize that this IP address existed only in the net configuration, not true on the WAP gateway number 1. This IP address is then changed by the destination net rule to the IP address 200.100. Basically, this is the traffic on the part number 1. This is the traffic on the part number 2. And after gateway number 1, the traffic is encrypted. And arriving on gateway number 2, the traffic is decrypted. And then already decrypted traffic is sent to the WebSMS again, but this time we apply the source net, we apply the new IP address 200.201, and the destination remains the same as we had on the part number 2. This way, WebSMS receives packet essentially from itself, but now it has totally different IP addresses in comparison to the original packet, and WebSMS has all the routes which is necessary to reply successfully to this ICMP ping. This way, we have successful connectivity. You may notice that the setup that we have will work only one direction. In case if we would like to ping from WebSMS Ethernet 2 back to WebSMS Ethernet 1, then it will fail. So we can easily check this, connecting to the WebSMS. And even to start checking, first of all, we need to figure out, okay, we want to ping what exactly? Because we cannot ping Ethernet 1 because this ping will go inside the box, it will not leave anywhere to the wire, and we cannot ping back to this source IP address of 200.201 because it will not match any net rule. And with this, we understand that to make it work, we need to add a new net rule, and we need to add a new static route on the WebSMS. So this is a part we will do right now. To start configuration, we need to go to Smart Console. In Smart Console, let's create a new destination net rule, but it will be in reverse direction. VPN DNet. And in reverse direction, the source IP address will be the WebSMS Ethernet 2 IP address, and the destination should be some IP address on the web gateway number 2. But it shouldn't be the real IP address, it will be the IP address which is in the encryption domain behind web gateway number 1, but it is not the same as the real IP address of Ethernet 1 on WebSMS. So it will be 100.100.101. And after that, we need to change the not real IP address of the SMS to the real IP address of the SMS 100, 100, 100. You may know that this is exactly mirroring the destination net rule that we had before. The next thing to configure is to configure routing. We need to log in to WebSMS, and we will need to add routes for the newly created source net and destination net IP addresses. Let's go to Clish and show what routes we have right now. Show configuration static route. We have two IP addresses. So this IP address is the IP address we used in the destination net rule, and this is the IP address we used in the source net rule. Let's mirror these routes, but right now this is the destination IP address that we use to initiate the reverse connection from Ethernet 2 of WebSMS to Ethernet 1 of WebSMS, and this destination address should be in 100.100 network, and the gateway should be gateway number 2. The other static route was configured for the source net IP address. We also need to create this source net IP address as well. Now we will hide it behind gateway number 1, so it is gateway number 1 network, and the destination should be the gateway number 1 interface, and we enable the route. Let's save config and double check. Now we have 4 routes, the routes for the net addresses on gateway number 1, and also the routes on the net addresses on the gateway number 2. We can exit. The next step for us would be to test the connectivity. Let's log in again. Now we can try to ping 200.200.101. This is the NAT address we used in the destination NAT on WAP gateway number 1. This ping is successful, as we can see. And the other address is the address we used on the destination NAT on gateway number 2. This ping is also successful. Now let's double check the logs. To check the logs, we go to logs and monitor. We see in the logs and monitor that the packets are a little bit out of order. So first we did a ping from WAP SMS Ethernet number 1 to the WAP SMS Ethernet number 2. So the source IP address will be Ethernet number 1 source IP address, 100.100.100, and the destination will be the destination NAT IP address of the WAP SMS Ethernet number 2. This is the encrypt packet. And then the source will remain the same, but the destination will be a proper destination, and this is the decrypt packet. The second we tested from Ethernet 2 to Ethernet 1, so this is the source of Ethernet 2 IP address, that's the destination NAT IP address of Ethernet 1, and this is the corresponding decrypt packet. So the connection now works both ways. Let's now review the connectivity in the reverse direction on the diagram. So the reverse connection also can be divided in 3 sections. So the first section is from the Ethernet 2 of WAP SMS to Ethernet 2 of WAP gateway number 2. The second part of the connection is in the tunnel, and the third part of the connection is after gateway number 1 and up to the Ethernet 1 of WAP SMS. Again, the corresponding packets you can see on the left. So this is the packet we have during the first part with the source of the original Ethernet 2 IP address, and destination is the destination IP in the destination NAT true. Then the second packet we have in the tunnel. In the tunnel, before the encryption, it will be all the same IP addresses for source of the original source of Ethernet to interface of WAP SMS, and the destination is the real IP address of the Ethernet 1 of WAP SMS. This traffic will be encrypted. And this is the third part of the connection. In the third part, we have a new source IP address, which we apply through the source NAT true, and the destination is the original IP address of the Ethernet 1 interface of the WAP SMS. So this way we have connectivity working in both directions, and now you have the new web setup where you can play with a VPN tunnel on 2 separate gateways. This is the end of the video, and as always, thank you for watching.